Okay. Happy to be here with you again. As always, I'm Nanli Nathaniel. You can reach me at Nanli Nathaniel 92210. This is my Twitter handle. So, in today's workshop, I'm going to talk to you about a very significant concept within the Ethereum protocol. Yes, within the Ethereum ecosystem called the consensus layer. So in today's workshop, it's just going to be an introduction to Ethereum consensus layer. So as always, I'm just going to make this thing very simple. Even if you're a complete beginner, you can see this workshop and have an understanding of what the consensus layer is. Without wasting much of your time, let's head on to the overview. So this is what I'll be showing you. What exactly is the consensus layer? We're going to be looking at why is it important. We're going to see Ethereum consensus evolution, and we're also going to look at core components of the consensus layer. We're also going to look at how proof of stake works, and we're also going to see key rules in consensus. So there are two things I want you to take notes as a result of before the workshop commences officially. I'm not going to exhaust everything pertaining consensus layer in this workshop. Number one is because I'm trying to make it simple, and like always, I want to make sure that every concept is well understood. We just focus on an aspect, get it, and then we move on to the other. And secondly, we know very well that there is an upgrade within the Ethereum ecosystem called the Pectra update, and that update will have a great influence to the consensus layer. And in the next workshop, I'm going to show you the significance of these upgrades and how it affects each of these clients that we have today. Alright, without wasting much of your time, let's head on. So what exactly is the consensus layer? Now the consensus layer is that part of the Ethereum blockchain that has the responsibility of agreeing the canonical chain and producing new blocks. It agrees on the behavior of nodes, agrees on the behavior of blocks, and how blocks, the state of each block on the blockchain space, how each blocks are arranged. So that aspect where blocks are arranged canonically, that rule is left for the consensus layer. And the major purpose of that is to ensure security, validate block, prevents double spending. So the reason why the consensus layer is specifically responsible for the state of the node, state of the block, is so that we can have more security and so that we can validate each blocks that are added in the network, and it prevents double spending. We'll look at these things in a more better light. So there's a concept merge. So initially, the blockchain, Ethereum specifically, they were using the proof of work. But this transition, which we're talking about as the merge, Ethereum now is using proof of stake. We're going to look at this thing in a more detailed way as we continue. And this proof of stake basically is Ethereum using Beacon chain as the consensus. And all of these things, we'll look at this thing, especially when we start writing our codes. You look at how the Beacon chain works and how it is responsible for producing new blocks and agreeing to the canonical chains. And we'll look at all of these things together. But for now, I just want you to have an understanding of how or what the consensus layer is. So the next thing I want you to understand is why is consensus important? Why is consensus important? So consensus is important is because it achieves agreement, ensures all nodes have the same view of the blockchain state. So we have different nodes that are running in different parts of the world, and each node, maybe a transaction can be happening in a particular node. Now the reason why the blockchain is so unique is because each transaction is distributed across several nodes. So how each node will be able to have access to the transactions that are happening on a particular node is through the consensus. So the consensus ensures that every node have the view of the blockchain state. So every node, depending on the type of node that is running, will have at least a snippet, not really a snippet now, but what is necessary Yes, yes, at least is a snippet of the transaction that is happening in the blockchain state. And the next thing is it prevents attacks, protect against double spending and fork attack, and enforces rules. Validators follow strict rules or face penalty slashing. So this is why the consistency is important. After agreeing to the state of the block, it prevents attack. It also enforces rules. Validators follow strict rules or face penalty slashing. Validators, we'll look at these things shortly. I know some people will be asking, what's a validator? Don't worry, we'll understand this. Like I said, I will make emphasis again. The reason why we're taking this very simple is so that when we get onto the code base, we will have a clear understanding of how these things work. So secondly, so I want to now explain the merge. That's basically what the consensus evolution means. So initially, before the merge, Ethereum was using proof of work, and after the merge, Ethereum was using proof of stake. And remember what we spoke about proof of stake, right? Proof of work basically means miners. So before we have nodes, people will literally need to mine them. But yes, people mine. But when we get to after the merge, which is the validators, we now have stakers. And before the merge, energy intensive, meaning it consumes a lot of energy before you mine a node. But right now, energy is efficient. For somebody to run a node, you just need to stake. And then we have for the merge happened September 15, 2022. It's just very recently. And the very, very significant concept of this merge is the introduction of this guy called the beacon chain. So the beacon chain replaces mining with staking. So remember how nodes are added to the blockchain. Initially it was with mining, but right now validators will only need to stake. And the reason why staking is important, staking is possible, is because of the presence of beacon chain, the consensus client. Amazing. All right, so what are the core components of the consensus layer? What are the core components of the consensus layer? The number one component of the consensus layer is the beacon chain, the beacon chain. So the beacon chain coordinates validators. Remember what we said in the previous slide. So the beacon chain coordinates validators and it stores validators registry. Number two, the core component of the consensus layer contains the validators. Now, all of these components is very important you take note of it, because when we go into the code base, the first thing we need to find are the components. Where exactly is the beacon chain in our code base? And is it doing this thing that we are seeing? We'll look at all of these things. And we'll also look at validators, and we'll run back to our code to see these validators, does it actually propose and attest to blocks? And another core component of the consensus layer is its fork choice rules. Decide which chain is correct. Finality gadget, confirm blocks as final. Reward penalty, incentivize honest behavior. So these are different core components of the consensus layer. I know you just need to have an overview of this thing, like we said earlier on, is an introduction. But as we dive deep, we'll be looking at the code base to understand how these things work and all of that. So how proof of stake works. So remember we said the reason why this proof of work is how proof of stake works. The reason why proof of stake is possible is because of the presence of the beacon chain. So how proof of stake work? It works when validators deposit 32 ETH. Remember, now validators deposit 32 ETH is them trying to have a node running. Initially, before the proof of stake, we have the proof of work, which only involves mining nodes, and it takes a lot of energy. But now we have the beacon chain, which make proof of stake possible. And because of that, we have validators, and before a validator can run a node, there must be a deposit of 32 ETH. But there seem to be a lot of upgrade, and that's why I told you we can't go further in our workshop today. In my next video, we're going to look at these things in a more detailed way because of the upgrade. I stated that before we started. So we said selected at random to propose block. So how proof of stake works is that now validators are selected at random to propose blocks. Other validators attest, vote on proposal. So when a block is proposed by a validator, other validators, they attest and vote If that block is to be added, consensus is reached when enough votes are collected. Validators are rewarded for participation. Penalties for being offline or dishonest. So what this means is that how the proof of stake works is that it is basically operated by validators. That's the whole logic of the Bitcoin chain. Head on. Now, what are the key rules in consensus? The key rules in consensus. We have proposer. That's number one rule in the consensus proposal. It proposed the next block. Attester votes on the validity of a block. Aggregator collect attestation and makes them efficient. Builder BPS, we call them BPS. Builds block, that's optimization. The reason why we need to know about these things, I will always emphasize, is when we dive deep into code base, you will really enjoy why these things are being said. Moving forward, without wasting much of your time. So basically, like we've seen, we've covered this. We've covered what the consensus layer is, why is it important, consensus, Ethereum consensus evolution, core component of the consensus layer, how proof of stake works, and key rules in consensus. So in our next video, we're going to be looking at the upgrade and how it affects or influences the consensus layer that we have today. So so this will be the end of the workshop. If you have any question, you can reach out to me on Twitter. This is my Twitter handle, nanlenata92210. I'll be so pleased to have a talk with you. So see you in my next video.